So now we're on a new board and we're talking about solving inequalities algebraically. Inequality means that it's not the same as an equation like we did yesterday, where at the end of the question you have an answer. X is equal to 9 or 10 or 52 or some value, some discrete value. For inequalities, you tend to have answers which are between certain boundaries. So anything from, let's say, 5 to 25 or 2 to 7 or -5. So it's an interval. It's a group of numbers. So that's the big difference between an inequality and an equation. Equations tend to come down to a particular value. Inequalities tend to be answered with another inequality. That is to say, it's somewhere greater than this or less than that, or somewhere, from infinity. We'll see in a minute what I mean by all of that. So we're solving inequalities algebraically. And the first inequality that we're solving is that x minus 8 is greater than or equal to 3. By the way, I usually like to just check in to make sure that everybody is back with me when I rejoin the board. How about Keontae and Nicholas and Noah? Keontae, Nicholas, and Noah, are you all there? Keontae, Nicholas is there, Keontae, and okay, perfect. All right. So turns out, just like yesterday when we were looking at the domain for that question on the dimensions for the box, if you remember that question, we actually had some inequalities that we had to solve, and where we're saying it has to be greater than 0. Well, we're going to do the same kind of thing here. We're going to solve this inequality, and for this inequality, we're going to sort of treat it almost like it's an equation. We're going to say, okay, since it's x minus 8 is greater than or equal to 3, we're just going to throw that minus 8 onto the other side as a plus 8. So it's just like when you solve an equation. So we should end up with this. X is greater than or equal to 3 plus 8. And therefore, x is greater than or equal to 11. As simple as that, right? You might have thought, okay, is it going to be something complicated? No, it's not. It's just like solving an equation. Another way of writing this, so we're not saying x is equal to 11 only, we're saying anything greater than 11. So 11, 12, 13, 14, all the way up to infinity. Another way to write this answer is to put the 11 with the infinity on the other side. We talked about doing this kind of thing before, right? So, giving answers in intervals. We talk about the use of intervals. So here's a way that we can use it. And why am I using a square bracket? Does anybody remember why I'm using a square bracket on the left and a round bracket on the right? Why is it square on the left? Does anybody remember why? I should hope you do, by the way. Why is 11 square? Why does 11 have a square? Because it's included. Thank you, Caris and Rylan and Emily. And yes, and Noah and everybody else who chimed in there. But we never ever put a square bracket on infinity, because infinity is really just a concept. It's like saying what's out there on the end of the universe is infinity. So that's another way of answering it. 11 is included because it says greater than or equal to 11. So that's included. There you go, folks. The first one is out of the way. We've got that one nailed down. We can move on from there. Second question. So it looks again like we can answer this by just doing the stuff we normally do with an equation. Except there's one little twist to it, which I'm going to show you in a minute. I'm going to say that -4, put it on the other side as a +4. So minus 2x is less than 12 plus 4. Okay. So that minus 2x is less than 16. Okay. So what would the next step normally be when you're solving an equation? It's not an equation, it's an inequality. But what do we normally do at this point to isolate that x? Anybody? Anybody divide by -2? And Noah is ahead of me on this. Jumped out ahead of me on that. Absolutely correct. So we're going to divide both sides by -2. You're correct about that. But when you divide an inequality by -2, division or multiplication, by the way, division by a negative, and my short form for negative is a minus sign with a VE, will flip the inequality or reverse the inequality. So yes, you're going to end up with x on its own. You're going to end up with minus 8, but instead of it being less than, it's actually greater than. All right, so Noah is absolutely right. So it was just two, you wouldn't flip the sign. Absolutely, Janai, you would not flip the sign, right? It would still just be the way you would expect it to be if it was an equation, if it was positive. But dividing by a negative does flip the sign on an inequality. So the answer to this question is that x is greater than, not equal to, but greater than 8. Sorry, minus 8. So how do we write that? Here's how we write it. Minus 8 to infinity. The difference now is that in this case, let's see what Harris is. If it was 16, you would you still flip the sign? It was minus 16. Oh, absolutely. As long as you're dividing, okay, Harish, I just saw your question. As long as you're dividing by a negative, you still have to flip the sign. The only difference is that you'd have that x is greater than positive 8 because you're dividing a negative by a negative, right? But the answer would still be greater than rather than less than. Okay, Harish? Are we good with that answer? Does that make sense? Got it. Perfect. All right. So another way of writing the answer is minus 8 to infinity. All right. I'm not saying that one is a better way of writing the answer than the other. I'm just giving you both ways. But here's the important point. Division by a negative means you have to flip the inequality. Exactly what Janaya said a couple minutes ago. All right. That's good. Let's keep going. Now, what if I gave you something that looked like this? It's obviously a quadratic, so when you multiply those out, you're going to get a quadratic. And I'm asking for where this is greater than 0. So this is different because I can't just simply, if this was equal to 0, then I just use a zero product law and I'd be done, right? Do you have to write the answer in interval notation when you're done? No, not really. As long as you realize that the answer is, in the case of the one we just did, all right, I'll accept both ways of writing it, whether x is greater than minus 8 or minus 8 to infinity. I'd accept both. Both, I think, are perfectly legitimate ways of writing it. Okay? So that's my answer to that question, Noah. Okay, let's get back to this now. So if it's a quadratic, and I'm asking for where it's greater than 0, I wonder if there is a simpler way for us to solve this. I know the way the book does it, and for those of you who want to take the strategy the book uses, which is some sort of a case analysis, by all means, you do that. I don't think that's the best way to do it, though. I'm going to show you in a minute what I think is the best way to do this. But let me take some ideas, right? Something times something else is greater than. We're not talking about equal to 0. Foil it, Janaya thinks. Okay, and then what would you do after you foil it? That's my question for you. Kayla says foil it as well. What would you do after that? I'm just taking your ideas for now. Right? Foil it out and then what? Because remember, you're trying to figure out where this thing is greater than 0. So how can we do that? Right? Not just where it's equal to 0. Just where it's equal to 0, then we all know that we can just zero product law it and we're done. Like what we did yesterday. Just find x alone somehow. I'm not sure. All right. I'm told it was the Chinese who had a saying. I don't know whether it's actually Chinese who came up with this. Is that a picture is worth 1,000 words. If I had a picture of this function, it's easy to answer it. So, do we know what this looks like if I had a graph? Well, we know if it's in factored form, and that's why I think leaving it in factored form makes more sense. We know that there are two zeros on this graph. One of the zeros is at minus 3, and the other zero is at 3 over 2. Can we all agree on that? Does that make sense, first of all? Before I go any further, Noah, Rylan, and Keontae, everybody else think that this is good? Apart from those 3 people, Karis? Okay, great. Great, Harish, thank you, Achan. Okay, so I'm going to draw this. I just said picture is worth 1,000 words. So if I draw this, it should look something like this. Oh, that's one of the best graphs I've ever drawn. It actually goes through the 2 points. Whoa. Go, Mr. Kamak. Okay, let me go back to black now. All right, now, I think we can answer this question now. I'm looking at a picture of the graph, and the question is asking, where is this graph greater than 0? And all greater than 0, oh, look at that, getting applause. Thank you very much. All greater than 0 means is, where is the function above the x-axis? That's what greater than 0 means. Anything which is above the x-axis is greater than 0. Well, that happens anywhere to the left of -3. So I'm pointing to it right here. Right? This function is above the x-axis, anywhere to the left of -3, anywhere to the right of 3/2. Okay? Let me say that again. The function is above the x-axis, anywhere to the left, because it's going to continue going up as it goes more and more to the left. It's going to continue going up as you go more and more to the right on the other side. So once you are above the x-axis, you're positive. So here's how I'm going to write my answer. There are 2 ways of writing the answer. I'm going to show you both ways. One way is to say this: minus infinity up to -3 union, which means I'm adding it to anywhere from 3/2 to infinity. Okay? So once I go from minus infinity until I get to -3, I'm above the x-axis. In between these two, I'm no longer above the x-axis. Once I get past 3/2, I'm above the x-axis again. So that's why my first answer is anywhere up to -3, starting from minus infinity, and anywhere from 3/2 up to positive infinity. The union, okay. Union means I'm adding 2 regions together. So I'm saying that U means it's the set notation for union. So I put that on the side here. So U without the stem, actually. Let me erase that. When you see that, and I want you to be using that when you're writing these answers for inequalities. So this U means union. Okay? So you're putting those 2 regions together. It's this or this. Now, if you're going to write it with an inequality sign, be very careful, because you're not supposed to use the word and, you're supposed to use the word or. So I'm going to say that x is less than -3, or, not and, x is greater than 3/2. I won't get into the technical reasons why the and is not what you should use. It's actually or. It has to do with intersections of sets and that kind of thing. So I'm just going to say that I want you to use that language if you're going to use the greater than signs or the less than signs. So you might want to just not want to use the greater than less than sign. Just use the interval brackets, because it's probably much easier and shorter, I think. Why isn't the -3 included? Because look at the question. The question says greater than 0. It didn't say greater than or equal to 0. It just says greater than 0. If it said greater than or equal to 0, then I would include that -3. Do you see what I'm saying, Janaya? Right? Because it's not, because if you're at -3, now you're equal to 0, but equal to 0 is not part of this. It says greater than 0. Okay, good. All right, so there you go. A picture is what I need to answer the question. Once I can draw it, I can answer it. Now, the textbook, like I said, has a different approach, and you're welcome to use their approach. I'm not trying to dictate how you should do. I've said this to you before. I'm not trying to dictate to you how you should do anything in math, right? I'm going to show you one approach, and if you find another approach that consistently gets you to the answer, and I don't mean cheating and going to the back of the book, that's not an approach, that's just cheating, okay? But if you can find a consistent method that allows you to get the answer, a logical, step-by-step, mathematical approach to do it, then I'm okay with that, right? So some of you, for instance, don't like the Magic X method, fine, don't use it. I'm okay with that. Right, so we've done the first 3 questions fairly quickly, fairly easily. Let's move on. Now, when we get to this, it's now a cubic function. And my advice to you is continue using a picture. If you can draw it, you can answer it. That's my contention. If you can draw it, you can answer it. So my advice to you is get used to being able to put it into factored form, because if it's in factored form, it's easy to figure out where the zeros are, and it's easy for me to draw this. So look at this function and help me to put this in factored form. Can anybody suggest a way that I could factor? We've done some work with this before. When we're solving polynomial equations, we did have to factor and use a zero product law. But we're doing the same thing now. Can you help me to factor this? Can anybody suggest? Look at you, Harish. Look at you, Janaya. You're ready with the grouping, right? How did you all even know that you could group this? Did you use that little sort of test that I taught you a couple of days ago as to how you know you can group it? Or did you just sort of guess? How did you know you could group it? You did, Janai, absolutely. And that's what you need to do, right? Test it out first before you start plugging in values of x, which is, a little bit of a it's a long sort of drawn out method. I'll be honest with you. I don't like doing it myself, but I still have to do it sometimes when I'm trying to solve these things. So if I can find another way to do it, I'm going to do it. Right. So I know that the factor by grouping will work if the 2 times the minus 45, I'll show you again, if this number times this number is the same as this number times that number, which it is. They both give you minus 90. First and the last multiplied as the same number as the middle two terms. Yes, Karis, absolutely, absolutely. Okay, so let's go ahead and try to factor by grouping then. Okay, what would be the common factor for the first two terms? And by the way, Jeremiah made a point yesterday, and I should repeat his point, that you can actually group the first and the third term together, and then the second and the fourth term together. That works as well, right? It still will work out, but and you still get the same answer, by the way. Just with anything in math, you're not getting a different answer by doing it a different way. You just have a different route to getting to that answer. That's all. But let's just say that we're going to stick with the first two terms. What would be the common factor between those first two terms? Anybody? X squared, Janaya says. Right? Nicholas says x squared as well. Perfect. Okay, so let's put that x squared on the side. Open up a bracket. And I'm going to ask for help again. Right? When I factor out that x squared, what am I left with? What's left inside the bracket when I factor it out of that? 2x plus 5, Joel is saying, and Janaya is saying the same thing. 2x plus 5, I agree. Okay, what would be the common factor for the second one? Joel and Nicholas, boy, you guys, they're just on fire. Look at Emily and Riley. Excellent. Minus 9. So minus 9. And then when I factor that out, thank you, Janaya, what do I have when I factor out that minus 9? Joel and Emily and Karis are all saying the same thing, the same 2x plus 5. All right? And I remind you that this is less than or equal to 0. So it's still the same question. Now, the common factor is the 2x plus 5. And then I have what's left over is x squared minus 9. That's all less than or equal to 0. And of course, I can factor the x squared minus 9 again, which in this case would give me x plus 3 and x minus 3 is less than or equal to 0. Thank you, Nicholas. Thank you, Janaya. So now I'm ready to draw this. Right? You should all be able to draw this on a piece of paper in front of you or wherever. I'm not going to, ask you all to do it on your whiteboard. I'm just going to go ahead and put my picture in place based on what I know from those factors. I have a plus 3. I have a minus 3. And I also have what looks like a minus 2.5. So minus 5 over 2. So there's a 0 that comes from this, which is minus 5 over 2. Minus 2.5, that would be somewhere around here, roughly speaking, minus 5 over 2. Okay? So I'm ready to draw this, and I don't think I'm going to have as much luck as I did the last time. Something tells me I'm going to mess this one up, but here we go. Here we go. It has a positive lead coefficient. Look back at the equation again. Positive lead coefficient of 2. It has the 3 zeros I have here. It's cubic, so it should go from quadrant 3 to quadrant 1. So here we go. Up, down, back up again. I'm getting good at this. Okay. All right. So there you go, folks. There is my graph. Let me go back to black now. Well, actually, it's not that good. Now that I think about it, it's really not that great. Anyway, the important thing we need to answer is, where is this less than or equal to 0? The picture is all we need, right? I'm not asking you to go on Desmos and draw this, right? That's kind of cheating, right? If you can factor it and if you can draw it, you can answer it. That's the bottom line, right? And I've just drawn it for you based on the zeros that I have and based on the end behavior that I have. I know it looks something like this. So I'm just going to throw this out to the room now. Maybe Rachel. Rachel, do you think you know any part of this function which is less than 0? Any part at all? Give me between 2 points that you think are less than 0. From here to here. Just give me what you think those are. Go ahead. Well done. Thank you very much. So here's my first solution. Negative infinity to negative 3. But before I put a bracket on that, and I'll ask anybody this, not just Rachel, what kind of bracket should I put on that? A square or a round? Anybody can answer. Square or Jeremiah, what do you think? Square or round on this one? Square or round? Why? Perfect. Perfect. Excellent. So you're not only talking about when it's less than 0, you're also talking when it actually is 0. And at minus 3, it is equal to 0, right? On my graph, on minus 3, the function is actually at 0. So that's part of my answer. Union. So remember that union sign now. That's kind of important. Let's see. Neil, can you help me out with any other part which is below the x-axis? All right, you got the first part, so minus infinity to minus 3. Yeah, good, excellent, excellent. Do you see any other part of this graph which is below the x-axis? So if you look at what I just got from, I think it was Rachel. Yeah, Rachel. All right, she was correct. Anything from minus infinity to minus 3. Is there another part of the graph where it's below the x-axis that you can help me out with, Neil? Remember that less than 0 means below the x-axis. So where else is the graph from minus 5.2 to positive 3? Absolutely. Absolutely. And if you think about what Jeremiah just said, we're going to put a square bracket on that. So minus 5 over 2 all the way up to 3. Square bracket on both. The only place I wouldn't put a square bracket, thank you, Neil. The only place I wouldn't put a square bracket is on infinity, if it's a less than or equal to or greater than or equal to question. That's the only place I wouldn't put a square bracket, because infinity is not considered to be an actual number. Thank you again. Is there anywhere else that belongs in my answer? Is there any other part on the graph that I should put in to my answer? What do you say, folks? So between Neil and Rachel, we have 2 parts. Is there any more in this answer? Or have we completely answered the question for where it's less than or equal to 0? What do you say to that? Anybody? Is there any other part that I should include, or am I done? So square, okay, square Janai said, yeah, it's a square, but I'm still asking, is there any more to the answer? And a lot of people are saying no to that. Janai, what do you think? Is it yes or no? Is there more to the answer or not? No. And you're right. That's the whole answer. That's it. That's done. There's your answer. That's the whole answer right there. Okay, good stuff, folks. Good stuff. Now, this question, I'm going to be doing it two ways, and I'll explain what I mean by that later on. I want us to answer the question first for when it's less than or equal to 0. Then I want to answer the question of where it's just less than 0. Turns out they're not the same answer. For all kinds of reasons, they're not the same answer. Very similar. And some of the stuff that we're going to do to answer the first question, we can use that to answer the second question. But first thing we need to do is try to draw this. Where is this less than or equal to 0? What do people recommend I do to be able to draw this function? Let me get from the class some ideas. So we're focusing on this question. We'll get to this question later. We're not doing this one yet. We're doing this question right now. The one in the box is the one we're doing. Can you suggest how I might be able to solve this inequality? Any ideas as to how I could solve that? What do I need to do next? I'm throwing it to the whole class, not just one person this time. What's the strategy here? How do I solve this? X cubed plus 3x squared minus 4. I know we tried factoring by grouping before. Division, Harish says, that might be involved. That might be involved. But what's the first thing we need to do? Do the magic X. Karis says, here's the problem with the magic X. The magic X is great for quadratic functions, except this one is cubic. So that's kind of why the magic X doesn't really address this one. So any other ideas? Yeah, it wouldn't work for this. No. Any other ideas? Where do we start? What do we do? I want to try to draw this, because if I can draw this like the last few times, then I can solve it. If I have a picture, I'm good to go. Okay? So how are we going to draw it? That's the challenge. If I'm not using Desmos, how am I going to draw it? Can we factor it? Because what Harish is saying kind of is where I'd like to go with this. If we can factor it, can't we draw it at that point? Okay, so how would we factor it? We've been doing this for the past couple of days. How would we factor x cubed plus 3x squared minus 4? Factor theorem. Thank you, Harish. Okay, and the first step in the factor theorem is what? What's that first step in the factor theorem? Come on, folks, work with me here. First step in the factor theorem is what? What do we do? How do we get started? Yeah, we're going to use a factor theorem. He's right. Harish is right. But what do we do to start off this factor theorem? Silence in the court. Come on, folks. We've done this before. Shouldn't we try to find that first 0? I know it's trial and error, right? Do we look at the minus 4? Yes, we do. Thank you, Riddy. Look at that minus 4 and start thinking of factors of the minus 4. We always start with 1 and minus 1. And unfortunately, we're going to have to slog away with this and try to find the first 0. So minus 2 and 1, okay? So we're going to try the 1 and minus 1 first. We're going to start with that, Travis, right? And then go from there. So I'm going to start off with 1, because 1 is a nice, convenient number to work with. So that will be 1 cubed plus 3 times 1 squared, which is just 3. 3 times 1 squared minus 4. Well, that's just 1 plus 3 minus 4. Guess what? All right? The 1 worked. That's good. So if 1 works, I don't know where you said minus 2 and 1. By the way, Travis, just so you know, for 4, we should be looking at plus and minus 1, plus and minus 2, plus and minus 4. But looks like the 1 worked right off the bat, straight out of the gate. So if 1 works, what is the factor then? Give me what one of the factors is if the 1 works. What's one of the factors here? Putting in 1 works, x minus 1. Thank you very much. Therefore, x minus 1 is a factor. And what do we do with that again? That we found that x minus 1 is a factor? Come on, folks, it's all factor theorem stuff here, right? What do I do with that once I know that x minus 1 is a factor? we divide. And I'm going to use the good old synthetic division, which says, put the -1 on the side. I'm going to put some numbers along the top. And what number should I put along the top, folks? Help me out. Give me all the numbers that belong on top for this table. Give me all the numbers in order. First number should be what? So it's 1, followed by 3, followed by what? No. Thank you, Rachel. Thank you, Emily. Thank you, Karis. Followed by 0, then the -4. Some people are forgetting that that 0 needs to be there when you're missing one of the powers. So you're missing a power for an x to the power of 1. I have a cube, which is the 1. I have a squared, which is the 3. But I don't have an x to the 1, so I have to put a 0 in for that, and then I put in the -4. So if all of that's right, I should get a 0 right there. Let's get this done. Bring down the 1. So that should be 1 here. -1 times 1 is -1. 3 minus -1 is 4. Remember that you're minusing. -1 times 4 is -4. 0 minus -4 is +4. -1 times 4 is -4. And there you go. There you go. That represents the result of the synthetic division. So I'm going to rewrite this now as the first factor, which is x minus 1, followed by, drop a degree, x squared plus 4x plus 4, there's no remainder, and all of this is less than or equal to 0. Just let me remind you what we're doing here. Can we factor the second bracket? Can we factor this bracket again, the x squared plus 4x plus 4? The answer, of course, is yes. Can somebody factor that for me, please? So x minus 1. What would that second one look like factored? X squared plus 4x plus 4. So I'm getting x plus 2 from Joel. Okay. So x plus 2 and another x plus 2. There you go. It's x plus 2 times x plus 2. Or x plus 2 squared. Good. So I think we're ready to draw this function now. How many zeros does this function therefore have, and what are the zeros? How many zeros do we have in this function? How many zeros do we have? We have 3, Joel says. No, it's actually 2. Kristen and Rylan and Rachel are no, well, Rachel had 3. It's actually 2. There are only 2 zeros, but one of them is a double zero or an order 2 0. So the zeros are, so we need that to be able to draw the graph. The zeros are 1, which is an order 1. And the other 0 is at -2, which is an order 2. Okay? So the 1 is an order 1. The -2, yes, Riley, is an order 2. Good. I'm ready to draw my graph now. So I'm going to slide over here where I have more room. And I'm going to put my zeros in at 1 and at -2. And now let's think about the end behavior of this function before we try to draw this. This function is, let me scroll back over here. Oops, sorry. This function is a cubic function. Lead coefficient is positive. So I'm thinking it should go from quadrant 3 to 1. It has to have these 2 zeros. But one of them is a bouncing 0. So I'm trying to think of what this might look like now. All right, so bouncing on the -2. All right, so let me get my red here. So I'm thinking it's going to look something like this. Bouncing on that, come back down, and then come back up again. That's what I'm thinking. Okay. I'm going to change my color back to black. That would represent my interpretation of this graph. No, let's answer the question. I want you to see the graph. Here's my graph. The question was, where is this graph less than or equal to 0? Less than or equal to 0. We're going to use that same graph when we're answering this question later on, because it's the same function, but instead of being less than or equal to, it's now just less than. Let's get to the graph. I want to throw it out to you. Where is this function? Where is this graph less than or equal to 0? Folks, what do you say is the answer to that? From minus infinity to minus 2, all pass from Omar. Okay, Omar. All right, hopefully just maybe 5 minutes. From minus infinity to minus 2, Carrie says, okay. So is that it? Is that the whole answer? And then from minus 2 to 1? Okay, and Nicholas seems to agree. So Karis, so is everybody on the same page with that? So with Rylan basically, and everybody else who came up with those answers, you agree with Emily? See what Emily said. Emily said from minus 2 to 1 for it to be less than or equal to 0. So for Emily, it's just between minus 2 and 1 apparently. That's what Karis seems to be agreeing with, just between minus 2 and 1. All right, I'm seeing another answer here. Janaya says minus infinity to minus 2 and then minus 2 to 1. It's what Rylan said. Minus infinity. Ah, interesting. Interesting answers. Anybody have a different answer? I'm just curious right now. Does anybody have a different answer for this? Or is everybody convinced that we already have the answer? Because unfortunately, that is not the answer. I'm going to write the answer down. And you might be surprised at my answer. Here's the answer to this question. Where is this less than or equal to 0? The answer to that, come back over here. The answer to this question is from minus infinity, that part I agree with, up to 1. Why did we not stop at minus 2? Why did we just go straight past minus 2? Right? The fact is we said r equal to 0, so we're not going to stop at minus 2 because the function minus 2 is part of your answer. It said r equal to 0. So why do we stop at minus 2? Why do we make a distinction at minus 2? All right? All of this stuff is less than or equal to 0. So from minus infinity all the way over, let me go back to the graph again, all the way over to 1, it's less than or equal to 0. Right? Everything from minus infinity, including 2, all the way up to here is your answer. Right? So that means that I don't have to make a distinction between when I'm at 2, or minus 2 rather, because that's just part of my answer. I'm just trying to go back here. So the answer is just minus infinity to 1. That's it. No, it's a different question when I ask this. So now I'm asking the question, where is this less than but not equal to 0? Only when it's less than 0. Now, if that's the case, the answers that you were all giving me before now make sense, right? And I know you put square brackets rather than what you had there, but really what you're doing is you're including the minus 2 in both of those regions, which means I don't need to make a distinction between the two answers. But no, I need to put a different answer for this one. For this answer, for this question, let me erase this here. For this question, no, I'm going to say minus infinity, yes, up to the, what was it again? Up to, where was it now? Up to the minus 2, not including minus 2, union with minus 2 up to 1 not including the 1. So if 0 is not included, it wouldn't, let me see what you're saying. If 0 is not included, then it would not include the -2, is what we're saying, Karis, right? So we're saying it's anything just short of -2, just below -2, Karis, just to answer your question. All right, so that's why my answer that I'm giving now, Karis, represents so it is less than but not equal to 0, because I'm not including -2. That's why I put a round bracket on the -2. On the -2 is a round bracket because I'm saying will be part of the answer. Yeah. Okay. You mean that my well, it's actually okay. Okay. Let me just make sure I'm clear. I'm clarifying this now. For the answer that I just gave up here, let me underline it in red. For the answer that I just gave up here, I'm saying that -2 is not included in the answer, right? Because when you're at -2, you're equal to 0, and this says less than 0, but not including 0. So that's why I'm putting minus infinity up to -2. Then I'm going from -2 to 1, right? So on the graph, if you notice on the graph, let me move this over, right? Once I start at minus infinity, I go all the way up to -2, but I can't include the -2, so I stop there. And I go from -2 all the way up to 1. Of course, after 1, the graph now goes above the x-axis. So there's no more there's no more parts to this answer because everything after 1 is now greater than 0. I can see now for the bottom answer, -2 is included, but not stated for the top. Yes, there you go. There you go, Karis, right? So I see yes. So I think we're on the same page now. The -2 is included in this answer, but you don't really have to state it because you can just go straight past it. I know that some people put it, and I understand why. I think it was it Karis who said this originally? Let me go back and see. It was Rylan who put the minus infinity to -2 and then the -2 to 1 and put square brackets on the -2. Really, you don't need to put it that way because of the fact that the -2 is part of your answer. So stopping at -2 doesn't make any sense. You should just continue going through -2 since it's just part of your answer. All right. Is everybody clear on what we just did? Does that make sense? I was asking for Sharisa earlier on. Is Sharisa now with us? All right, that was a while ago that I asked Sharisa. Sharisa, are you there with us? Where's Sharisa? Sharisa going once. Sharisa, I was calling for you earlier. Couldn't find you. Okay, you got to stay with us. Got to stay with us. That's important. Okay? All right. Now, did you follow everything that we did, by the way? Did it all make sense to you, Sharisa, what we just did for that answer? Did everything make sense to you? Okay. All right. And I believe that was the last question I had for today. It is.